Denominators that differ by sign. We have two different cases here of denominators differing by sign, but they are handled very differently. In this first case, we can see, looking at these denominators, because they are both subtractions but written in the reverse order, these differ by a factor of -1. To see how that's true, we can take the denominator 5 minus x and just swapping the order of the terms, write that as minus x plus 5, and then factor out a -1 because our first term is negative, and that would change the signs of both terms, giving us -1 times x minus 5. So the denominator -1 times x minus 5 and the denominator x minus 5 differ just by a factor of -1. When we're dealing with this kind of situation, the simplest way to fix it is not to be really formal about finding an LCD, but just to go and correct one of these expressions by multiplying by -1 over -1. And the way I would choose to do that is starting with the one that is in kind of the unusual order here. This is not in order of descending powers. I would choose to correct this one by multiplying the top and bottom by -1 to give it the same denominator as the other expression. It does get a little confusing if you try to be overly formal about the LCD on this. It stays very simple if we just think of it instead as a correction. So that our whole expression now will look like this: 3 over 5 minus x times -1 over -1 plus x plus 2 over x minus 5. We won't change that one at all. When we multiply the -1 over -1, this becomes -3 on top, and distributing the -1 into the denominator gives us a -5 and a positive x, so I'm going to just go ahead and write that as x minus 5 right now. And now I have a common denominator for both of these expressions, and I'm ready to go ahead and add. Adding the numerators gives me -3 plus x plus 2 in the numerator, and x minus 5 in the denominator, and then I simply combine the like terms -3 and plus 2 to get -1 for those two terms. The x does not combine with any other terms, so we now have x minus 1 over x minus 5 as our final answer. This problem stayed fairly simple, even though it might be a little bit tricky. It did not involve lots and lots of heavy algebra to get to our final answer. If we contrast that with our other example of a denominator that differs, our other example of a subtraction in which the denominators differ only by sign, in this case they differ by just the sign of one term rather than both terms. So these denominators can't be made to be the same by just a simple correction such as multiplication by -1. Instead, these have no common factors, and this isn't really a special case at all. When there are no common factors at all in the denominators, we need to include both of them in our LCD. So I'll go ahead and start by just defining my LCD to be the product x plus 4 times x minus 4. This problem will get a little bit heavier computationally, but not too bad. So we have x minus 3 over x plus 4, and I am missing the factor x minus 4, which is in my LCD but is not in the denominator of this. So I'm going to multiply this by the ratio x minus 4 over x minus 4, and Looking at my second rational expression, 2 over x minus 4 is missing the factor x plus 4. So this one I will multiply the top and bottom by x plus 4. And multiplying out this whole numerator is where it gets a little bit computationally more involved than the last one did. So I'm going to start by thinking about how to FOIL this. Since we have a binomial times a binomial here, we're going to have to FOIL these to get our numerator. Whereas the second expression is going to involve the distributive law a little bit more. But all of this really is going to happen in the next step. Just writing our whole numerator out, I have x minus 3 times x minus 4, which gives me x squared minus 4x minus 3x plus 12. And when I distribute into the x minus 4, I want to make sure to take that sign with me. So it's the whole negative 2 that gets distributed into those two terms, not just the 2. Make sure that minus sign gets applied to both. That becomes minus 2x and then plus 8. This is all still over the LCD. And so in the next step, we're just going to combine like terms. Our x squared does not have any like terms to combine with it, but our x to the power 1 has negative 4x, negative 3x, and a negative 2x, all of which will combine. And also our number terms with no x in them at all, we have a plus 12 and a plus 8, which will both combine. So that our next step, we have x squared minus 7x minus 2 more x's is negative 9x. And then plus 12 and plus 8 combine to give me plus 20. And at this stage, it's reasonable to put that LCD back in. X plus 4 times x minus 4. We should examine the numerator to see if it is possible to factor it, in case there might be any common factors here. But a quick inspection shows us that no, that is a prime polynomial and we do not have any common factors, so this would be our final answer.